Good morning, Honors Chemistry. Morgan here, and this is for Thursday, March 19th, 2020. We're going to be spending today going over worksheet on pH number 2, and then from this point forward, I'm going to assume that you are competent at calculating pHs and that we can move on into some other subjects. Typically, what would have happened today is we would have gone over this and then had a very short lab that's not going to be possible, but I am actually working on getting a home version of that developed and can get that out to you shortly, I'm hoping. Okay, so we went over worksheet number 1 yesterday. Hopefully you got pretty good at pushing buttons on the calculator. Today, number 2, we start off by knowing that we have a pH of 5, which means we have a pOH of 9, because pH and pOH added together will equal 14. The H plus is 10 to the negative 5th, because hydrogen ion concentration is equal to 10 to the negative pH, and the hydroxide ion concentration is 10 to the negative 9th, because hydroxide is equal to 10 to the negative pOH. Since this has a pH less than 7, it is acidic. We have a pOH of 13, which means we have a pH of 1. The H plus is 10 to the negative 1. The OH minus is 10 to the negative 13th, and again, something that is acidic. Now, we switch from just doing the magnitudes, the powers of 10, to actually having some significant figures involved. Now, at this point, we're given an H plus of 1.00 times 10 to the negative 7th, and that contains 3 significant digits. So pH is equal to the negative log of the H plus concentration. pOH is equal to the negative log of the OH minus concentration. So, if I take the negative log of that, I get 7.000. 3 sig figs here means we go to 3 places after the decimal. Remember, the places after the decimal in the logarithm are the measurement, and the number in front of the decimal is just the magnitude. So that would be the equivalent of the times 10 to the negative 7th, and the 0.000 would be the equivalent of 1.00. Okay, so that also means we have a pH of 7.000 and an OH minus of 1.00 times 10 to the negative 7th, and that is neutral. Now, one of the ways to get the OH minus when we know the H plus is to use Kw, which equals the concentration of H plus times the concentration of OH minus, which equals 1.00 times 10 to the negative 14th, and we developed all of that in the lecture outline. Okay? So now here we have 1.00 times 10 to the negative 8th, which means our pOH is 8.000. Now, let's look at that on a calculator, just in case you're not totally comfortable with the logarithms. The negative log of 1.00 second EE negative 8th, close my parentheses, gives me an 8. That's where that comes from. So, the pH is going to be 6.000, because that plus that must equal 14, and this is 1.00 times 10 to the negative 6th. Okay. So now we have something that's not a 1 there. I'm going to stop doing this in my head, and I'm going to start using a calculator. By the way, that's acidic. So, since this is H plus, the negative log of 3.00 second EE negative 9, make sure I type that carefully, yep, is 8. Now it's 5228, so I'm going to call it 8.523. 8.523. Then 14 minus 8.523, and I get 5.477. Okay, Now, second log gives me 10 to the x. I put in my minus sign, 5.477, and I get 3.33 times 10 to the negative sixth. And that's basic, okay? So if this is 6.75, this is 7.25, okay? We see that from 14 minus 6.75, okay? Then, to get the h plus, second, 10 to the x, negative, and I can even use second answer, hit equal, and get 5.6, and the next number is at 2, so I'm not going to round that 6 up. 5.6 times 10 to the negative 8th. And a slightly different approach, 1.00 second EE negative 14 divided by 5.6 second EE negative 8. And that gives me 1.8 times 10 to the negative 7th. Since I was 2 places after the decimal, I have 2 sig figs, okay? 2 places after the decimal, 2 sig figs, etc., etc. Now, just to show you that both of these methods are valid, let's do second 10 to the x negative 6.75, and I'm going to get 1.8 times 10 to the negative 7th. And this is basic, okay? So within sig figs, I'm getting the correct answer each time. Okay, so I have 4.56 as a pH. 14 minus 4.56 gives me 9.44. This is subtraction. We look at places after the decimal. 2 places after, 2 places after. Okay, so clear that out. Second, 10 to the x, negative 4.56. That equals 2. We're going to call that 2.8 because the next number is a 5. 2.8 times 10 to the negative 5th. Then second 10 to the x, negative 9.44, and I'm going to get 3.6 times 10 to the negative 10th. And this is acidic. So now if I pH of 0.09, 14 minus 0.09 is 13.91. That's very basic. Wow. So second 10 to the x, negative 13.91, and I'm getting 1.2 times 10 to the negative 14th. Clear that out. Second 10 to the x, negative 0.09, and I'm getting 0.81. All right. So here I have a 2.00 times 10 to the negative 14th, negative log 2.00 second EE negative 14, and I'm getting a 13.6989, so 13.699. This is going to be 0.301. 14 minus that answer gives me 0.301. Okay, then for my hydroxide, second 10 to the x, negative second answer, and I get 0.5. But I'm going to put the 0, 0, okay, to keep it to 3 sig figs. So go in a slightly different direction this time, just to show you it can be different. 1.00 second EE negative 14 divided by 6.54 second EE negative 5th, and I get 1.52. The next number is a 9, so we're going to call that 1.53 times 10 to the negative 10th. Now I'm going to take the negative log of that answer and get 9.816. 3 sig figs, 3 places after the decimal. 14 minus that answer, 4.184. And that's going to be basic. Okay? So tonight let's get really good. Finish off worksheet on pH number 3, okay? And then tomorrow we're going to go into acid-base nomenclature. Hope you're having a good day and stay safe. This is Morgan signing off. Bye-bye.